Have you ever seen the branches on a tree or the scales of a pine cone and wondered, why are those arranged like that? Is it organized? Is there a method? Well, in fact, there is. The very thing that links together the life sciences and mathematics, the Fibonacci sequence, is hidden all throughout nature. The sequence is a simple set of numbers found by Leonardo Pisano Bigolo, who, as you may guess, is now referred to commonly as Fibonacci. He compiled a bunch of math ideas from India into the book Liber Abaci, and one of the components was a question that asked how many rabbits would be produced in an enclosed area if every month each pair produced another pair, only reproduced after a month of age, and never died. This is demonstrated here. Every rabbit starts out without a nose. It takes 1 month for them to gain the pink nose and thus begin reproducing. The answer to this rabbit question became the Fibonacci sequence, f of x equals f of x minus 1 plus f of x minus 2, with the restrictions set that f of 0 equals 1 and f of 1 equals 1. Which is just a fancy way of saying that the next number in the sequence is the two prior numbers added together. This is seen all throughout nature, but through other forms called the golden elements. The golden spiral, for example, is created because the sum of the squares of a series of Fibonacci numbers will be the last Fibonacci number used, multiplied by the next. For example, 1 squared plus 1 squared plus 2 squared plus 3 squared plus 5 squared plus 8 squared equals 8 times 13, or 104. A spiral can then be drawn through the boxes. The golden ratio, on the other hand, is about 1.61803, denoted by the Greek letter phi. Every Fibonacci number divided by the one before it will have a quotient approaching phi. It's also seen on line ABC if line AB is to BC as AB is to AC. Now after the stuffy math, we get to the cool part. Where do we see the Fibonacci sequence? In short, everywhere. The branches of any tree add up to a Fibonacci number. The number of petals on most flowers is a Fibonacci number. The number of spirals of pinecone scales and sunflower seeds is a Fibonacci number. The golden spiral and ratio are seen as well. The spiral represents the growing proportions of things, as seen clearly in the nautilus shell. The golden ratio is seen in plants as well. Because the golden ratio is applied to a circle, it would give the angle 137.5 degrees. And that's the angle of rotation that the leaves of many plants display before the next leaf is grown. Now we must ask why. Why does this seemingly random set of numbers appear everywhere? The most logical answer would be that organisms have come, over time, to use these ratios and values to use space most effectively and gain any advantage possible.